Hey guys, welcome to the local host lab, and today we are looking at problem 146 LRU cache. So we have to design a data structure that follows the constraints of a least recently used cache. So we have been given a initial capacity of this cache, which is going to be positive, and it returns the value of the key. So the value is going to be stored in key value. So like a map, and we have been given two methods. Put and get. So put will put the key into the cache and get will retrieve its value. And this needs to happen in constant average time. If the key exists, return its value. Otherwise, we have to return -1. Capacity is going to be positive. Okay. So here, since this is key value, we have to use a map. And the next thing is how we are going to maintain least recently used. So we have to have a data structure which can ensure that we are also storing how matlab, when which key is least recently used. Because if the capacity is full, we have to evict the least recently used value. Here we have to use linked list, but not any linked list. We have to use doubly linked list along with map. So let's see. We have to use map and doubly linked list. So what is a doubly linked list? So suppose if we have nodes head. So this as well as this. matlab, think of it like a box. Wait, I'll do it like this. So suppose we have head, one node, another node, another node. So linked list में there are only one linking. Here there are two, next and previous. This is next and this is previous. Its previous, it's going to be null, the head node, and its next is going to be null. Okay, so this is how a doubly linked list is. So in this node, we are also going to store key value. So here, see, we are having a map where the key is going to be key and the value is going to be the node itself because we have to do it in constant average time. So I've created a node class key value, and this is a doubly linked list node. So it will have previous and next. And I've also taken head and tail. Why? Because I want to define my boundary. Suppose if my capacity is 3, right? So between head and tail, there will be only going to be 3 nodes. So why it becomes easier for me to traverse if I know these are my head and tail are my boundaries. So I've created, for now, I've initialized capacity. I've created a blank map and empty map and head as with 0, 0 and tail as 0, 0, and I've linked these. Now I want to get the value. If I do get, I should get the value. So I've been given key. So first I will check it in map. If it doesn't contain, we are straight away returning -1. If not, then we can rest assured that it is in map. So map may we can get the node and see if we are interacting with a particular node, then we have to update its position also because this is now more the frequent the right now we are uh, interacting with this node, so we have to put it in the first of the linked list, front of the linked list. So whatever position it is in the linked list, we are simply removing it and we are inserting it at the front, and we are simply returning its value. How we are putting the uh, node, how we are maintaining. So first we'll check if the map already contains, we are simply removing it so that we can enter a new node. So we have removed it, and then we create a new node with this key value, and we are checking if our map size is barabar capacity. We have to remove this last least recently used element, which is present at tail.previous. So we have removed that, and then we have inserted our new node. Now let's see how we are inserting and removing. First, we have to put it in the map and see if we are inserting this new node. Suppose I have to insert, this is one. I have to insert a new node at the front. So two's next is going to be this, and its previous is going to be this, correct? And this next is going to be this, and its previous is going to be this. So that's what we have done. Node dot next becomes head dot next, and node dot previous becomes head. And head dot next, which is node 2. Dot previous, we have to make it node, and head dot next is node. And for remove, we are removing it from the map, and then we are doing key node dot c. If we have to remove this node, so is the its previous's next should be this, and its next ka previous should be this. That's what we are doing, and this should work.